I will call it one of the rare blessings of this pandemic that we were willing to do 17-hour Zoom sessions as an idea. No one ran screaming from it when we talked about it. So it's been incredible today. Just exceeded all expectations, and Suzette and Buzz and Xavier and everyone else has just made it possible. So thank you all. It's been, of course, just so wonderful to hear people's stories. It's been emotional and just a tribute to Eric's legacy and both scientifically and seeing all the people's lives that he's touched, and very much, my own as well. He's been very influential to me. I really count him as, I have a sort of core set of mentors: Tom Webb, Steve Jackson, and Eric. And from each of them, I feel I've received gifts. And in Eric's case, very much this mission of open data and inclusiveness and building these resources that we all pitch into and we all receive from as a way of doing our own science and then growing our discipline science at the same time. So what I'd like to do today is talk a little bit about the Neotoma paleoecology database as this emergent community resource that, as Russ has talked about and others have talked about, really came from Eric and Russ and others. And I've often felt Eric was always maybe 15 years ahead of the rest of us, and we were helping build out to and catch up to the vision that he had in his head all along. And definitely want to acknowledge, Simon Goring, Jonathan Nelson, Jessica Boyce, and lots of other people. This is very much a team effort here. One thing I just want to begin with is, as the current executive chair of the Neotoma Leadership Council, which is the governing body for Neotoma, and as we really wrestled with mourning Eric and missing him and carrying on, as we kind of worked over the fall and had team meetings to figure out who picks up what and how do we get this done and how do we get that done, that Eric is irreplaceable in so many ways. And the metaphor here of so many different hats that he wore within the Neotoma group and team. He was the originator and ongoing lead developer of the Tilia software, this major resource for visualizing data and putting data into Neotoma and making sure it's done right and curated. He was the data architect to build the underlying relational database that sat behind Neotoma, that is all the relational data structures that the data sit in on the Penn State server. He was the lead data steward. He was a person that people went to if they had questions about this taxonomic name or that decision, or how do I handle this, top bottom data set and so forth. So he was a lot of things, a lot of people within Neotoma. And so as we have worked in that, as we'll see, different people have picked up different parts of all the many things that Eric did all by himself. And that's just, the starter list. We could go break down all this even more. He was the person you emailed if you had a problem. He was our tech support person. He was to make sure that the data was in good shape. He was the authority who minted new stewards. He was one of our key taxonomic experts. He, as everyone has said, he was sort of a community liaison, reaching out to people all the time. And we could keep going through this. And so again, Eric's role in Neotoma just cannot be understated. It's just have an obligatory field photo of Eric. And just a couple stories here. This is going back to Lake Tulane. This was mentioned earlier as one of Eric's iconic sites. This incredible record that he and George Jacobson and Bill Watts and others worked up, demonstrating that Florida seems to be doing the opposite from the rest of the Atlantic, that when the North Atlantic is cold during the Heinrich events, Florida is warm and wet. So some really interesting insights into heat transport and cooling of heat, perhaps around the Florida Peninsula during the Heinrich events. And in early 2000, just before that Amsterdam workshop that Eric led for the African pollen database, Angie Prodi, you can see in the right photo there, leaning against the pillar, for a postdoctoral fellowship, is now going back to Tulane to look at pollen and megafaunal spore signals and fire signals, to look at these interacting dynamics during the Heinrichs before and after human arrival. And so you can see there on the right that, Eric is a storyteller. That was, we're kind of setting up, we're on the shoreline and we're kind of, assessing the lake. Eric is, doing what he does. One of the things he did so well is just tell stories and reminisce and help us get oriented to what's important about this site. And then, everyone's, wrapped, as you can see there. And then that left photo, I picked that one to share because you can see that we're out on the platform and it's kind of windy. There's gear blowing around and we're in motion and we're getting ready to tie off and bring a core up there. And Eric's at the center of that. He's just kind of still and watching everything. He's really making sure that we're doing it right, that we haven't screwed up a drive, that everything is done just the right way. And I have to say that was my one and only ever field trip with Eric, and I feel so fortunate because I can really see how people said that he really was one of the best. I have been in the field many times, and I learned a lot of new things from Eric on that trip. And this is the other part of what Eric has spent so much of his time on, and some other people showed these workshop photos here. This was from a sort of a paleo hackathon a few years ago from EarthCube funding, bringing different paleo scientists from different data resources, talking about how do we connect and interlink our different data resources there. You can see it's a whole room of people talking and trading ideas. And again, Eric's at the center of this one, and you can see how he's just listening, right? He's really thinking about how other people represent their data and what's important to them, and then how do we integrate it all? So his ability to integrate and listen and connect, again, was just incredible and really important for the development of Neotoma. And so this kind of community building aspect is really central too. So Neotoma itself, I think, again, most people know it, but just to kind of review and state, our mission is to be this support global change research. I always sort of view it as bringing paleoecology to the table. There was global remote sensing networks and Ameriflux towers and global paleoclimatic records. And our community has this incredible archive of records about past species dynamics in response to past anthropogenic and environmental change. But our records are inherently site level and disaggregated. And through these kind of community resources, we can now start to be and assess past biospheric dynamics at anywhere from site scale all the way up to global scale here. And those stats you see there in lower left, in Neotoma, we now have over 78,000 sites, basically dots on the map. We have 40,000 data sets at those 19,000 sites and over 7 million individual data points among those data sets and sites. And you can see that is updated as of today. During the remnants for Eric today, Simon has been busily updating, and we've been sort of chatting back and forth to get this kind of updated for this presentation. So these are hot off the press results here. And really, moving our field from quote unquote a little data field to a big data field, and able to do more and more powerful analysis, the kind of emergent analyses that Xavier was talking about. Just some of the trajectories of growth and accumulation of data. These are all sort of data volume from last about 10 years or so. Growth in number of author names stored in Neotoma. Now we have over 6,000 author names stored in Neotoma. Over 100 countries have records in Neotoma. Over 40,000 data sets, 7 million data points, 7,000 publications, 19,000 sites. And again, how when you start to look at these numbers, you start to realize how important it is to have a resource like Neotoma. No one of us, not even any single research team, can do this anymore. This is now kind of scaled up past the level that any single person or team can handle. We need to have these kind of community efforts to curate and gather and upload and work with this kind of scale of data to do the kind of big scale science that we need in this kind of rapidly changing biosphere. This is a record that Simon put together yesterday showing the uploads to Neotoma on a monthly basis. So it's the same essentially information as the last plot, but now looking at data sets, and the bars are color coded by data set type. So you can start to look at the different kinds of data that have gone into Neotoma over the last year. And this is sort of a month by month upload record. And so if you look carefully, you can see that the light green here is tested amoebae. So Bob Booth and colleagues were very busy last summer getting a lot of tested amoebae records up. The dark green is pollen. So there's been a pretty steady input of pollen records by different groups around the world, notably the European Pollen Database and others putting data in. There's been diatom records and ostracod records, water chemistry records. That was a big push by Allison and Dawn about a year and a half ago. And so all this is happening. And then you can also notice that we had a big drop off in about July of 2000. That was when we were doing this big back end shift. And as we were doing that, we had to basically halt all uploads to Neotoma over the period of a couple months. And then in the midst of that, as there's Jonathan Nelson, Mike Stryker, Simon Goring, Jessica Boyce, Eric Grimm, myself, were all working really hard to get this sorted out and done. Eric passed away right in the middle of that, and so this was this, it was a difficult time. I would say it was one of the hardest times for the Neotoma group, and at so many levels, you can see here. And so you can really see there's a story behind the data uploads here, and there's just touching on the deeper parts of losses that go with Eric. And you can also see the recovery that comes with this too, that since then, there has been a steady growing accumulation of records going back into Neotoma. And to me, that is, kind of one of the messages here of, we have lost Eric, and it's a terrible loss, but we also have this ongoing community dedication to the things that Eric helped build and begin, and you can see that regrowing here in this diagram. So, as someone else said, Eric was nice, but he did not tolerate. He was not receptive to bad science. He was incredibly incisive and also kind, and that's a difficult combination to strike. And he did it incredibly well. And so, Neotoma has always been built around a science mission. And so, this idea of open data then supporting a broader community. And I really see this as, this sort of complementary approach that Neotoma holds all this data in it. People are careful about curating and putting data in. That then makes it available to all kinds of different research initiatives. There's a bunch of acronyms on the right there: Land Cover 6K, SCOPE, and HOPE, and Climate 12K, and some Arctic initiatives, Abrupt Change, that's an Exceed project. They're all working with Neotoma data to do these sort of continental to hemispheric to global scale analyses of past ecosystem or climate or archaeological human environment interaction analyses. And there's sort of these two-way sets of services that they receive data that's been kind of cleaned and aggregated, so they're not starting from scratch. And in return, and I think HOPE particularly is really a remarkable example of this, there's a lot of return services back to Neotoma. Records that aren't in Neotoma yet get added to Neotoma. There's often ongoing fixing of little errors or incompletenesses that come up along the way. Age models get updated, and so forth. So there becomes this really productive, virtuous cycle between Neotoma and the research communities and projects supported by Neotoma. And Neotoma has a Publons page, and so we use that to kind of track papers that are citing or mentioning Neotoma in them, and the number of times those papers are cited. So since of course everything in academic at some point gets down to metrics, we have 779 papers that have cited Neotoma at some point, either because they've used it or they put their data there. Those papers have a collected H index of 81. And so it's just one way we can, of course, in the most crude way possible, we can track some of the impact and usage that Neotoma is having. And this is, for those of you who know Pollenviewer, this is something that I, met several of us, Tom Webb, Phil LeDuc, Brian Schumann, and myself, developed at Brown back in the day using the North American Pollen Database. This is an updated version of Pollenviewer, now supporting the simultaneous display of multiple taxa. You can see we have spruce and oak and grass and hemlock all shown here. You can see the blue ice sheets melting away. And this has been developed by Adrian George, who's a PhD student here at UW-Madison. And again, in this commitment to open data and science, it's all drawing data directly from the Neotoma, so it can get updated on a fairly regular basis, as opposed to the Pollenviewer maps, which are basically one-off maps that were never updated after they were created. And the code is open. It's up on GitHub. Other people could develop versions of these maps for other parts of the world or other taxa. So again, it makes these tools, these sort of online web services powered by these open data resources available to anyone that wants to work with them. Then we have, and as one example of that, there's a new paper coming out. This has been a global rate of change analysis that has been led by Suzette Flantua and Andres Model. They're postdocs on the HOPE project at Bergen. And again, powered by Neotoma and data that they have collected as part of that project and are adding to Neotoma, helping with these data mobilization campaigns, we can now really achieve some of these kind of global assessments of rates of vegetation change over the last 18,000 years, and building upon some of the techniques developed by Eric Grimm and George Jacobson, taking pollen diagrams, coming up with some community metric of rate of change, and scaling that up now to sort of global scale, continental scale rate of change analyses. And so there's this database element to Neotoma. There's certainly the powering science element to Neotoma. But I think also what to me is clearer and clearer is that there's a whole community of people built around Neotoma, and Neotoma has become this node, and that this actually comes from Simon Goring talking about communities of practice and sort of this sort of nodal interface that people come together to bring their data in, work with it together, and then share it outwards. And in some ways, this event that we're at today was made possible by the Neotoma structure of different data stewards in different parts of the world, working with Eric and able to build out their networks in different places to help make this wonderful event happen. And so this is just a recognition of all the people who are data stewards. They are uploading data to Neotoma, and they've all been, they probably at some point, they've all had direct training from Eric. This is, Eric was very careful about making sure people knew how to do work with Tilia and do the data uploads right and make sure all, I's were dotted and T's were crossed. And I think Neotoma's reputation for high quality data supporting high quality science, again comes straight from Eric. This is a way of thinking about this that this is a graphic I put together a couple of years ago, but I really like as kind of a way of thinking about this now is recognizing that we are this community of overlapping roles. We have people who are generating new records. We have people who are synthesizing and analyzing multiple site level records. And we have data stewards who are in charge of kind of curating and making sure data gets into Neotoma or is updated and improved if necessary. And that critically, these are all overlapping communities of people. I wear all three hats. Many of us wear one or more hats. And it's really helpful to think about that way, because I think one of the key cultural barriers that Eric helped break through back in the day was a perception that it was a one-way chain, that the data producers gave their data to the data users and there was no return flow. And that was that question, like, why should I give up my hard-earned data to somebody else to do their science with? And nowadays, I think everyone gets that we're all creating and using and analyzing data and wearing different hats at different times, and Neotoma supports this. And if you watch the arrows there closely, there's different services being provided to and from the data generators to Neotoma and to and from the data synthesizers and Neotoma, or open community data resources more generally. And if we were to sort of say, as a community, what are our values? Like, what are we centered on? I would say, to a large degree, we are built around Eric's values. Being kind, being open in our data, and to inviting people in, being ethical in the work we do, and making sure people get proper credit and acknowledgement, doing the job right. There's one thing that defines Eric's approach to doing science was the details matter, and getting them right powers excellent science. Being science-driven, we don't make databases just for the sake of making databases. They're very mission-oriented and science-oriented. They're international. And again, one thing I've been really impressed by and touched by is how there's a whole generation of early career scientists in their 20s to 30s that are using Neotoma and have worked with Eric and are inspired by Eric. And sitting on the African pollen database session earlier, that was certainly a theme that kept coming back over and over again. So if we kind of look ahead to where we're going, I don't go into great detail here, but just to kind of show that things are continuing on. There's major efforts being planned for the summer to upload and mobilize a bunch of data for the African pollen database into Neotoma, led by Sarah Ivory and Marie Lazine. There's the Latin American efforts that Henry and Suzette and others have talked about. This Suzette is leading. There's an effort for the Indo-Pacific pollen database with Annika Herbert, Simon Haberly, Suzette, and then diatom mobilization work by Don Charles and Joy Hobbs and others. And then there's many other things on top of that. And so other communities are eager and ready to participate as well. And Neotoma has become, I think, a real beacon for people. And on the sort of the software side, there's always things being built out and worked on. We're always trying to make Explorer better, since Explorer is such an important interface and point of contact for so many people. Simon's been building out, the the digital object identifiers, the DOIs, and everybody's data sets can be properly cited and discovered and recognized. Socorro, who's on this call, has just joined the group, and she and Simon are working on the new generation of the R package that's in the process. And then one of the great bottlenecks is getting data into Neotoma. And so Simon and Ed Davis and others are leading an effort to try to do multi-site uploads and how to do that well and carefully so that we can keep these curation processes done, but at the same time at a faster clip than the site-by-site Tilia effort enables. And so just to kind of close here, just to really say that again, we have lost Eric and he is irreplaceable in so many ways, but there is this whole community that is carrying forward, and this is just a way of recognizing some of the people in that community. The Neotoma Leadership Council at left, the Neotoma sort of IT team at right, and then I can't list them all the many hundreds to thousands of people who have contributed data or are using Neotoma data, and all inspired by Eric. So thank you.